Okay, so we finished the first week of the course, and we're going to start today the second half of the course. In the first half of the course, what did we learn? We learned that if you have weak AC signals, you can amplify them. Okay, there's a number of ways to amplify them. You can use discrete components such as bipolar junction transistors, and using those we bias them in a special way, and we want to use the common emitter uh, solution to doing that because it gives us the maximum amount of amplification both in current and voltage, which means they are power generators essentially. Okay, so one way to do that, use discrete components um, using bipolar junction transistors, and mainly using the common emitter circuit to accomplish that. This is often done from some of the more simple type of electrical circuits. Okay, but if in today's world we're looking for some more complicated circuits, basically we also want to start out with analog and get into digital circuits. And for that we use the operational amplifiers. Operational amplifiers are more easy to use. I mean, they're very simple. They're integrated circuits that use transistors of different types to get your amplification, okay, and you can easily amplify using the resistor and capacitor type networks, but we can also do something else with that if we go the op amp. The op amp allows us to do some filtering as well. It allows us to actually do a lot of the mathematical um, things, such as the higher math things, such as differentiation, integration, and of course summation and subtraction as well, product, and so forth. Although the op amps allow you to do a lot of the math, the one thing that they also allow you to do, which we won't study either in this course or in the next course, is that it will allow you to actually take a signal and digitize it. That is, make it into a digital type of signal from the analog, which is a sinusoid, usually a alternating signal type. Okay, but we can digitize it using special operational amplifiers. Basically, they're mainly summing amps. But unfortunately, we don't have the time to study that completely, so we won't get into that. The other thing that the op amps do is allow you to create signals that are not the common sinusoidal signals, all right? So we will learn a little bit about that in this final week of this course, okay? So today and tomorrow we will talk about oscillators, okay, give you a number of different circuits that we can use to create oscillating type of signals, okay? The oscillating signals are used to generate power for different kinds of sensors or even applications such as sonar, radar, and quite a number of other things, okay? And later on we will see how we can use them to not only create specific type of waveforms, but actually do some shaping to create specific waveforms, very oddball shapes that we may need to do in certain applications. Okay, so let's get started, but let's not forget where we started from. We started from the basics of analog circuits, how to amplify and how to create some power. That power is going to have to be used a number of different ways. One way is to create a power that is pulsed out or given out in the different types of waveforms, and that's pretty much the subject matter of this whole week. Okay, so good luck on that, and let's carry on.